Hey everybody! Today we're going to try to solve systems of linear equations with three variables. That's right, not just x and y, but an x, y, and a z. Now these steps take a little bit of time to write out, so go ahead and pause the video on this screen, write down these steps, and then we'll continue from there. Alright, if you're all done, it's time to move on. Alright, so let's get started here with this system of three equations that has three variables that we're going to solve for. The very first step is to pick two equations and eliminate one variable. It doesn't matter which equations I choose. I'm going to go ahead and choose these two, and as you can see, whenever you write them out, the y's are going to eliminate each other. So x minus y plus 2z equals 3. Now, it's not always this nice, right? Like sometimes you have to use your elimination rules and maybe multiply one of the equations by a number, and we'll see that in a minute. So here we have 2x minus z equals negative 7. All right, now the second step is to pick two different equations and eliminate the same variable. It's so important that we eliminate the same variable. So now I can do like 1 and 3 or 2 and 3. Since I'm trying to eliminate y, 2 and 3 are already set up pretty nicely. So I'm going to take x minus y plus 2z equals 3 and 2x plus y minus z equals negative 6. And whenever I do elimination here, the y's cancel again. I have 3x plus z equals negative 3. Alright, so now, since we eliminated y's, now I just have two equations with two variables. Anytime you have that, you can just use normal elimination or substitution, whatever, and solve this system for these two variables. So we have 2x minus z equals negative 7, and 3x plus z equals negative 3. Now again, this is just working out really nice for us. Look, the z's are going to cancel each other right off the bat. So we have 5x is equal to negative 10, so x must equal negative 2. And then you're just going to go right back into all your elimination tricks here. Or not tricks, but all your elimination rules. This x is going to plug right back into either of these equations. I'm going to just plug it into the second one just for fun. So 3 times negative 2 plus z equals negative 3. So negative 6 plus z equals negative 3. Add 6 to both sides, and z is equal to 3. So now I have x, I've got z, okay, so I can just plug both of these back into any of my original equations. So let's plug them back into the very first, x plus y minus 3z equals negative 10. So substituting them in, I have negative 2 plus y minus 3 times 3 equals negative 10. Negative 3 times 3 is negative 9. Combined with negative 2 is negative 11 plus y equals negative 10. Adding 11 to both sides, we get y equals 1. So now I've got x, y, and z. But I want to write this as an ordered triple. That's the last step. So it would be negative 2, 1, 3. That's where these three planes intersect. Alright, so let's just jump right into this. Here we have a system of equations with three variables. So since we have three variables, I have to have three equations. So x minus 2y plus 3z equals 7, 2x plus y plus z equals 4, negative 3x plus 2y minus 2z equals negative 10. Alright, so step 1 says to pick two equations and eliminate one variable. So I'm going to go ahead and number my equations, 1, 2, and 3. So step 1 is just to choose two equations and to eliminate a variable. I can do this with any of them, but if I look here at 1 and 3, the y's cancel each other pretty easily. All right, so once I've chosen my equations, I can solve this using elimination just by adding the equations together. So I'd be left with negative 2x, the y's cancel out, minus z equals negative 3. And we're going to save this equation for in just a moment. All right, now let's try it one more time with a more challenging problem. So the first step is just to choose any two equations and eliminate one of the variables. So right off the bat, I can see that if I choose these two equations, the y's are going to eliminate. Now, I realize in both of these examples we've eliminated the y's. That does not have to be the case. So x minus 2y plus 3z is equal to 7. And negative 3x plus 2y minus 2z is equal to negative 10. The y's are going to eliminate. So x minus 3x is negative 2x plus z is equal to negative 3. Now, it doesn't really matter how I go about this. I know that I need to eliminate y. This has a negative y and a positive y. So I'm going to use these two equations. X minus 2y plus 3z equals 7, and 2x plus y plus z equals 4. Now here the y's don't eliminate, so I'm going to have to multiply everything in this equation by 2. So now I have x minus 2y plus 3z equals 7, and 4x plus 2y plus 2z equals 8. Now the y's eliminate. So I have 5x plus 5z is equal to 15. All right. Now I'm going to take both of these equations that I just solved for and use these to solve for x and z. So we have negative 2x plus z equals negative 3, and 5x plus 5z is equal to 15. So again, we have a situation where nothing is eliminating. I'm going to have to multiply this top equation by negative 5. In order to get a negative 5z here in this top equation. I could have divided all of this by negative 5. That would also work because that would give me a negative z. But there's always 1,000 ways to do it. That would give me 10x minus 5z is equal to positive 15. And down here, nothing changes. So I've got 15x is equal to 30. So the z is eliminated. Now I've got my x is equal to 2. And I'm just going to plug that right back into either of these equations. So negative 2 times x is 2 now, plus z equals negative 3. So negative 4 plus z is equal to negative 3. Add 4 to both sides, and z equals 1. So I've got x, I've got z. All I need is y. So I just plug this back into any of my original equations. So I'm going to plug it right back into the very first. X minus 2y plus 3z equals 7. Okay, so x was 2 minus 2y plus 3 times 1 equals 7. All right, this still has a variable, so 2 plus 3 is 5 minus 2y equals 7. Subtract 5 from each side. Negative 2y equals 2, and y equals negative 1. So I've got all three variables. My solution is 2, negative 1, 1. whenever you're doing systems of equations with three variables, the same situations still apply. Like you might have infinite solutions, you might have no solution. If you ever run into a spot where all the variables eliminate, right, from like two equations, and you end up at 0 equals 0, this would be a case of infinite solutions, because it doesn't matter what the variables are, like everything's always going to cancel out. You always get 0 equals 0. Now, if all the variables cancel out, so on one side of the equation you have 0, and then just any number besides 0, this case we would have no solution. And that's going to wrap it up for this video, but I promise we're going to practice a lot more of these in class. So, yeah, this is systems with three variables.